So we're going to do a problem here from the My Math Lab homework, section 2.2, number 10. We've got a system of equations and then the associated augmented matrix, and what we're going to do is come up with a solution. So first thing I'm going to do, we want to get in the first column we want to get an entry up here, upper left, and then zeros down here. So what I'm going to do is I'm going to do a couple of operations. I'm going to take negative 5/2 times row 1, add it to row 2, and have that become the new row 2. And then I'm going to do negative 7/2 times R1 and add it to R3 and make that the new R3. So the first step is if I take negative 5/2 times R1, I'm going to get negative 5, negative 15/2, 5/2, 0, and add that to row 2, which is 5, negative 1, 4, 1. And I'm going to get 0, negative 17/2, 13/2, 1. That's going to be the new row 2. And then for the second step, we'll take negative 7/2 times R1, we'll get negative 7, negative 21/2, 7/2, 0, and add that to 7, 2, 3, 1, and get 0, negative 17/2, 13/2, 1, and that'll be the new row 3. So taking this gives us our new augmented matrix, which will be same first row, new second row, 0, negative 17/2, 13/2, 1, and a new third row that looks like that. So there we are at that point. And what we'll notice here is the second and third rows are identical. So we can take, let's say, subtract row 2 from row 3 and have that as our new row 3. And what we get is first row unchanged, second row unchanged, third row becomes all zeros. Since they're identical, basically we've got only 2 equations for 3 variables, which means we're going to have infinite solutions, and we're going to have z as our parameter. Okay, so our solution will be x written in terms of z, y written in terms of z, and z as a parameter. So the infinite solutions will be, I can pick any value for z, and the value of z I pick will determine what x and y are. Right? So now to clean up things just a little bit, I'm going to multiply row 2 by negative 2 to leave us with this augmented matrix. So the first and third rows remain unchanged, and the second row will just be negative 2. So that will be positive 17, negative 13, and negative 2. So clearing stuff up a little bit, here we've got our first row in a way we like it, second row in a way we like it, or sorry, first column the way we like it, second column almost the way we like it. We just want to make this into a 0, and we'll see what happens. So from here what I'm going to do is I'm going to take negative 17 times the first row, plus 3 times the second row, add them together, and have that be the new first row. And these seem like odd numbers, but what I'm doing is I'm trying to make these coefficients be opposites. So when I add them, we'll cancel. So what will happen when I do this operation, I'll get negative 34 minus 51, 17, 0, and I'll be adding that to 0 3 times 17 is 51, negative 39, and negative 6. Add those together, negative 34, 0, negative 22, negative 6. That's our new first row. So we've effectively gotten rid of zero. So we've got this entry, zeros below. This entry, right here with the 17, zeros above and below. And what we have basically is we've got x, z, and the equals, y, z, and the equals. So what we can do now is I'm going to take the first row divided by negative 34, and I'm going to take the second row and divide it by 17. So the third row is all zeros. First row I got 1, 0, negative 11 seventeenths. So negative 22 over negative 34 is positive 11 seventeenths. Excuse me. And 6 34ths is 3 seventeenths. And in the second row, dividing by 17, I'll get 1, negative 13 seventeenths, and negative 2 seventeenths. So what these equations represent is x plus 11 seventeenths z equals 3 seventeenths, y equals y minus 13 seventeenths equals negative 2 seventeenths. And using a little algebra, we can rewrite these. X equals 3 seventeenths minus 11 seventeenths z, and y equals negative 2 seventeenths plus 13 seventeenths z. And that is the solution to our problem.